Alright, in this lecture we're going to finish our conversation about statistics. So we're going to look at statistical process control. So given a set of process control data, we're going to create a control chart of the appropriate zones and plot the data by hand. We're going to use the 8 Nelson rules to determine if the process is in control or out of control and name any rule violations. So to use the manufacturing to track quality, you show data on a control chart, and to use the control chart to determine if the process is running as expected. So basically you have your mean and you create 3 zones that go from 1, 2, and 3 standard deviations away from the average. So you have the 8 Nelson rules. They're similar in all industries. They may vary slightly with company and application. So you use the rules to determine if a process is operating as expected. To obtain certain combinations of points statistically occur infrequently that may indicate a problem within your process. So what is the first Nelson rule? The first Nelson rule is if a point falls anywhere beyond zone A, a value more than 3 standard deviations away from the mean may occur on either side of the mean. So any points that are outside of 3 standard deviations, your process is out of control. If you have 9 points in a row that occur on the same side of the mean, the actual values may be drifting away from each other. It can be sawtooth like this, but if you have 9 in a row on the same side, no. If you have 6 points that occur with an consistently increasing or decreasing trend, if this pattern continues, the process will eventually become unacceptable. Again, it can be sawtooth. It doesn't have to be a perfectly straight line. If you have 14 points in a row that alternate from one side of the mean to the other, this is saying that your process is unstable. If 2 out of 3 points in a row occur in zone A, so the process is close to the upper limit, you want to take preventative measures to fix it now. If 4 out of 5 points in a row occur in zone B, it's the same thing. You're approaching your upper limit, so you want to go fix things now. If 15 points in a row occur in zone Z, points can occur on either side of the mean. So if you have all of these points occurring in your tightly 1 standard deviation zone, it basically means your process is running too perfectly. So you might be able to loosen up some restrictions and possibly save yourself some money. And rule 8 is 8 points in a row occur beyond zone C. The points can occur on either side. The process doesn't run close enough to the mean, so your parts are never quite on target, so you might need to adjust the parameters of the process to tighten up. So let's look at an example. We have reactor temperature. The average is 40 degrees. So here's our 40 degree average. The standard deviation is set to 2 degrees, so that would be 42, 44, and then 46. So anything above 46. So what's wrong with this? Well, if I draw my mean and my 3 zones on here, you can see, well, first we have multiple points outside of our 3 standard deviations. We also have 2 out of 3 points occurring in zone A. And then we also have a nice linear trend, a nice increasing trend occurring. So what happens when we take the same process and we set the standard deviation to 5? So we get a new graph where now the brackets are further away. So we no longer have violations where any of the values are outside of our 3 standard deviation limits. However, we still do have 2 out of 3 points in a row occurring in zone A, and that linear increasing trend is still seen. So what happens if we look at this one where we have the average is 80 and the standard deviation is 5. So if we put our average and standard deviation lines on here, we can tell we have multiple points that are occurring outside of our end limit. We also have 2 out of 3 points occurring in zone A quite often, and we also have 5 points in a row, 5 points out of 6 occurring in zone B. So let's look at some statistics in Excel. We're going to learn how to create a histogram and cumulative distribution function in Excel. And we're going to look at the mean, median, variance, and standard deviation in Excel. So again, to use the average function in Excel, you just type average and highlight the cells in the range. It's both for population and sample mean. Population is the entire data set. Sample only represents a portion. Excel has two versions of everything else. We have standard deviation P, standard deviation S, variance P, and variance S. It's whether they use the entire population or a sample of the data. In this case, we're going to use the two different functions. You will get two different answers. This one is using the entire population, and this one is using the sample size. So if you turn on the analysis tool pack in Excel by going on the add-ins and making sure your analysis tools pack is on, you can open up the data analysis windows, and the data analysis windows allows you to make a histogram and cumulative distribution function. So here we have our high temperatures for October. So we want to calculate the bin size. October has 31 days, so the square root of 31 is 5.57, so we're going to have 6 bins. We're going to determine the range using the min and max function. So the range is the max minus the min, so our range is 30 degrees. So our bin size is our range divided by our number of bins, so we have 5 degrees per bin. Here's our histogram analysis. We're going to have bin labels. So to create the histogram and cumulative distribution function in the charts, we're going to go to data analysis, and under analysis, we're going to choose histogram. Once we choose histogram, it's going to open up a window where we can input the range. We can click the selection icon and highlight the data for a range. In this case, it's B6 to B36. And then we're going to click the back icon. We're going to repeat for the bin range by highlighting the cells that contain the upper values. We're going to identify a cell for our output location and check the cumulative percentage data chart. So basically, just going to pick a point where it's stored. So this is an extremely blurry picture of all of that information. Don't know why it's so bad. So let's look at it. So if we replace the bin values in the histogram data table for bin with the bin labels. So here's our bin, and we're going to replace them with our bin labels. Basically, I'm just going to copy and paste. This will change our axes labels. To make a proper plot, we got to change our vertical axis on the left to have a scale of multiple of 2, 5, or 10, and align it with the CDF percentage axis. You kind of want them to have the same steps. We're going to change the vertical scale on the right axis to be a maximum of 100%. It's important to do this. You want everything to look. So that's it for statistics in Excel. We are going to do statistics in MATLAB. We're going to do that in class. That is it for the content of the course, and I hope you had a great semester.